All right, good day everyone. This is Jason Straight with the Cloud Pass Virtual Group. Our presentation today is continuously deploy Azure Analytics and solutions using Azure DevOps with Phil Spokas. Before I hand things over to Phil, we do have a few announcements I just want to go through just to keep you guys abreast of what's going on with this virtual group. So the first thing is, if you haven't yet, I do recommend everyone subscribes to the virtual group at cloud.pass.org. The reason to subscribe is that we do on occasion have some last minute scheduling changes that is usually nice to get informed about, and that's the best way to find out about those scheduling changes. We did have a couple Thursday sessions over the last couple months that got rescheduled due to speaker illness, and just getting subscribed and getting that newsletter will get you informed of when those changes occur. Over the next few weeks, we do have a number of sessions coming up. We've got some Cosmos, we've got some geo-replication, we've got some on-prem data in the cloud, and lots of different topics that are coming up. So take some time to go and check those out and see. You can get to all those at that same cloud.pass.org website. If you are interested in presenting, we're always looking for new presenters or returning presenters. So you can go out to email and send me an email about it at cloud@pass.org, or if you'd like, you could go out to the Call for Presenters link that's on the cloud.pass.org website. Click that link, fill out the form, and we can get you scheduled. Coming this fall is Pass Summit 2019, and at this time, all sessions for the 2019 summit from the community call for speakers, all of those sessions have been announced. So now there's over 200 sessions out there on the calendar that you can go through and browse and see all the times in which there'll be and start to plan for it. If you have not yet registered for the Pass Summit, I would encourage you to do so. It's the premier Microsoft Data Platform conference. If you haven't not registered and you do plan on doing so, you can use a discount code from this virtual group at VGDISFKDQ. You can use that to get a discount of $150 US from your summit registration. This virtual group is part of a number of virtual groups that Pass helps to support. They cover areas such as DevOps and PowerShell, and they focus on languages such as Global Italian and Global Hebrew. It's a good opportunity to further your learning on data platforms. Throughout this session, you may have some questions. If you do, just go to the question panel, type them in, and at the end of the session, we'll go through all of those with time permitting and give Phil an opportunity to answer those for you. At this time, I'm going to hand things over to Phil Spokas with his session today, Continuously Deploy Azure Analytics Solutions using Azure DevOps.
Thank you, Jason.
All right, Phil, you should now be the presenter.
Okay, and I have shown my screen.
Yep, looks good.
Okay, great. So again, today's session is Continuously Deploy Azure Analytics. The focus is continuous deployment and talking about components that are part of Azure Analytics. I think Jason just showed a bunch of sessions there that would be deep dives into some of the technologies that we'll be talking about today. So as Jason said, I'm Phil Spokas. I work for Intellitech, which is a small company based in Spokane, Washington. We are basically a Microsoft shop. We do a lot of DevOps and Azure DevOps related work, as well as data analytics work, which I'll talk to you about a bit today. We're a Microsoft Gold partner for both DevOps and Azure Gold partners. We also execute DevOps fast tracks for Microsoft. There's a select number of partners that we're doing that for, and I'm actually on one of those engagements this week. And we do all kinds of other good technology stuff, and you can find out more about us at intellitech.com. So key topics for today are a bit of a background and overview of solutions that we've been deploying, and a particular solution that I assisted with a few months ago and was a topic of conversation for a SQL Saturday session that I did. And we'll talk about continuous deployment as well as the solution itself and a few of the components. So the basic overview here is a data analytics solution. This is a similar pattern to various solutions that we've implemented. The different component pieces may be different. This is also a fairly standard data analytics pattern these days, especially in the Azure cloud. So going from left to right, we have source data, which might be in data files, text files, CSV files, transactional systems in SQL Server typically, and also these days we're seeing things like integration applications or REST APIs that are providing data that needs to be integrated. In a particular situation that I was in a couple of months ago, these integration applications, basically wrappers for systems that this customer had out in their field that they were pulling data into. All those data sources were ingested via Data Factory. The Data Factory pumped that data, did some minimal processing on it, pumped it into Data Lake. They had some data analytics jobs that they perform on this data to crunch it. Then it gets spit back into Data Lake Store, and then it's pulled into Power BI. And so it's been refined, processed, normalized, denormalized, whatever the case may be, and then pulled into a Power BI data model and then displayed. Additional elements that are critical for this application as well include Key Vault for storing secrets, logic apps, which are a helpful component to help monitor the system as well as verify that the system is working, they're useful for sending notifications when things happen, and then logging. Logging is a critical component here. We want to make sure that the solution we put together is healthy. And again, my focus today will be on how we deployed a few of these elements or critical elements and the benefits of the deployment versus getting into dark, deep secrets on Data Factory in particular or Data Lake Analytics or anything like that. And it's basically illustrate what you can do with DevOps these days. And everything is getting DevOps-ified, if that's a word, even data analytics solutions. So when we talk about, excuse me, I'm hit an extra button there. The DevOps practices, we're talking about, hopefully you're familiar with DevOps. It's a, hot topic, big word. It isn't just one thing, not just a buzzword. It's really a couple of things. We talk about DevOps. We talk about people, process, and products. People, it's a team of people. It's not just operations people, DBAs, people operating on data or delivering data analytics solutions, or developers who might be building solutions, but it's also project management, product management, end users, all involved in a process to deliver a solution. We have the process itself. How do we actually get things out the door? How do we get our product built? How do we plan it? And then products would be the technology, the enabling technology. But that's not where we start. We think about, we get a team together, we are intentional about doing a better job of delivering our solutions. We define processes, we update processes, we streamline processes, and then we implement products to actually make this happen. This is all toward the goal of delivering value. We build these solutions so that end users can get value out of the solutions that we're building. So that's some background. Again, hopefully that resonates with people, and that's something you've heard before, and it makes some sense. I could talk for days about DevOps. I'm going to try and control myself and get to some of the demos here relatively quickly. Again, the other key component here is continuous deployment, and that is when we build something, when we develop it, we are creating artifacts. We want to get those artifacts from a developer, data scientist, data practitioner, data engineer, whatever that is, data analytics person through a pipeline out into production as automatically as possible, as quickly as possible. But we don't want this speed to impact quality. In fact, we want to improve the quality along the way. So we go through stages. All these stages, again, this may resonate with solutions that you're deploying today. It may not, but we typically talk about dev or a development environment. Excuse me, did it again. We talk about a test environment, validating that what we did is correct. A lot of times we're into situations where security, there's a specific security review that may or may not happen, or security may happen in different phases. Then we stage things for production, and then in production we actually go live. And through this deployment, we may have automatic movement. We may have manual movement. Somebody's manually approving something. But the bottom line is, anytime we deploy something, we want to do it through automation, through a script, and automatically deploy. To ensure quality, we have basic building blocks that we use to ensure quality. We manage our artifacts, our code. This includes database definitions or analytics models. We put these in source control, and we put in policies to ensure that when we add source or we check in source, we've got quality checks on the source before it ever gets built. When we check something in, we automatically build it. We create pipelines that stage or orchestrate artifacts through pipelines, and then we again talk about gates with that validate builds and our gates to ensure that testing happens and that testing passes. We don't just execute tests, we also check for results. Then once we get something out the door, we want to monitor it, where we put logs in place. We don't just log, but we also monitor the logs to make sure that what we get, if something happens or something doesn't happen, as often happens in ETL, right? You expect files to show up, they never show up. We're checking that and throwing alarms or throwing alerts if files don't show up in a staging directory, for example. And then going back to people and process, we define what it means, and I'm sorry, but my presentation is getting out of control here, so excuse me while I back up a little bit. We have a definition of done that says, hey, I'm done with a feature, I'm done with an additional piece of functionality when I actually see it in production, and my customers or my stakeholders, my users say, yeah, I got it, it's good, looks great, thumbs up, okay, then I'm done. I'm not done when I check it into source control. I'm done when customers are actually using it. And that's a collaborative effort for this whole team, an entire team, all the people who are involved in delivery. The DBAs, operations people, firewall, network, project management, et cetera, et cetera. Everybody's working together. So at the end of the day, what's the deal here? We're talking about delivering value. We want to deliver the value faster. We want to deliver it with higher quality and at less cost. Seems like you can't really combine those things together, but current state of the art actually allows us to do that. We automate processes, which eliminates errors. That reduces the amount of time it takes to actually build, test, and deploy. And that enables smaller incremental change. If we think about, let's say, classic ETL, all the steps that are required to actually deploy a change, there's so much effort involved, multiple people that are involved, maybe not a lot of automation. What ends up happening is a team or a developer or a data engineer will hold on to their changes and build up a whole bunch of changes and not deploy them because of the effort it takes to actually get the deployment out the door. If we back up a bit and we automate this, we're eliminating manual errors that might occur even if I've got things scripted. If I execute the script correctly, don't pass in parameters correctly, I can still create errors. So I put in a process that's more automated to eliminate the errors. upfront cost. It takes a while to put these scripts in place, but over time, I reduce the effort and reduce the cost, and that ends up enabling a smaller incremental change. If I make a change today, maybe it took me an afternoon, I'm comfortable putting that into source and pushing it through the pipeline and getting it out the door so that somebody can use it. Versus, if it was just an afternoon's worth in the old days, there's no way I'd be deploying it because it's going to take me 3 or 4 days to get the thing deployed. So we're turning that sort of deployment model on its head with continuous delivery. So moving on, the technology we're going to use is Azure DevOps, and specifically Azure pipelines. You'll see different elements of Azure DevOps. That my intent today is not to specifically demo or talk to you about all the DevOps features, but to focus on using Azure DevOps to deploy a couple of components of my DevOps solution. And again, I'm focusing on the technology itself and deployment, not in, let's say, we're going to talk about Data Factory. I'm not going into the nitty-gritty detail of what Data Factory does. Pipelines, though it says Azure in it, is really a platform-independent tool. It's a software as a service solution based in the cloud, and it's certainly Microsoft-centric and can do a lot with Microsoft-based technologies, C#, SQL Server, analysis services, Azure itself, but it can be used to deploy to Amazon Web Services, Java applications, PHP applications, and et cetera. It's also very extensible and can handle open source solutions like by integrating with GitHub and others. So the data analytics solution, I'm basically repeating the slide up front, and what we're going to transition into are going into a couple of components of this solution to demonstrate and illustrate how we actually do this continuous deployment. Okay, hopefully so far so good. I'd like to see a virtual thumbs up, I suppose, but I can't really see you, so I'm going to assume we're all good to go, and I'm going to keep rolling. The components we're going to talk about are an integration app, which is really Azure Functions, a monitoring app, which is number 2, which is really a logic app that's Azure construct, and then Data Factory itself and ways that you can do continuous integration and continuous deployment with Data Factory itself. So the first thing we'll talk about is an Azure function, and again, in my data analytics scenario, the Azure function is used to pump data into my Data Factory. We've used Azure functions to do other things like to run special logic on data that we've ingested into Data Factory. So Data Factory can use it as a data source, so we can also call out to Azure functions. So the interesting thing about Azure functions is there's a standard development, build, and deploy lifecycle that goes along with Azure function. A key thing with DevOps and deployment is that we want to validate the deployment. We've deployed a function. We want to make sure that it works. So that testing, setting up a gate, a pass-fail, is fairly critical. What I'm going to show today is a PowerShell script that actually runs in the pipeline that validates the function, but we've seen other technology used, which includes Postman, if you're familiar with that, or other more sophisticated testing frameworks. And that really, my recommendation typically when I'm putting these systems in place is start simple and then grow as your application needs it. So at this point, I'm going to switch over to my function app, and we'll do a quick little review here. I've now gone into Visual Studio. What I'm looking at is, again, a fairly simple function app, and I've got 2 functions here, a parameter function, which is just going to take a parameter and spit results back. Again, this is a very simple sample. The intent is not to go into all the crazy things you can do with the function app, but just to demonstrate the concept. I'm also have another function endpoint for my function, serviced by a HTTP trigger, so an HTTP request, or a REST API, is another way to say that. That will take in a parameter and then return a secret out of a key store. Not a real useful function, generally speaking, but not something you'd want to do. This is actually a publicly available function, so I'm not going to put anything that's super secret in here. It's just there to illustrate the point. And again, a classic software development lifecycle would be, hey, I've got some code, I've got a development environment, I'm going to build the code, test the code, and check it in. And that's supported here. And so I might say, I'm going to make a small little change here. I'm going to say, hey, pass not a secret, pass the secret in. And this is just if I don't, an error message that says if I don't pass anything in on the command line, I'm going to get a message. I can run this code locally, and Azure provides a local development environment that will actually kick up and run my Azure functions locally, so I don't have to run this on Azure to actually test my function. So, of course, because it's a webinar, everything's running about 1/3 the speed or 1/4 the speed as per normal. So, be a little bit patient while this comes up. So this is firing up functions, and then we can see, hey, I've got a couple of endpoints that are being supported here. So I can grab that endpoint, and I can fire up a browser, and I can run my test, and it'll come back and say, hey, pass the secret name on the query string, dummy. Okay, so I can say, oops, and I don't really expect this to work. Secret name is equal the secret. Again, what this actually does isn't really important. Oh, never mind. See if I can get it right. Apparently, I don't know how to type anymore. Or no, actually, it's running and getting back to me again. Not all that important what this actually does. But hopefully you get the idea. I can run this locally, and it says, yeah, your secret name is actually the secret. It's telling me you don't have data, and that's okay. Not really relevant. I'm just executing this API. We see that it works. Okay, so great. I can stop this function, and now I say over in my Team Explorer, I've made this small little change to my CS. There's a couple of other demo changes that I made locally. And I'm going to say, hey, I fixed the error message. I'm going to go ahead and commit this. And what this is doing is taking this code and committing it local using Git. I'm going to sync this change and push it. And actually, I'm going to do a pull here first. I wanted to hit the pull, not the fetch, because I made other changes. So I need to merge those into my local commit. I'm going to go ahead and push that up to. Try that again. Yeah, so I've successfully pushed that up. Great. So I made a small little change. I pushed my function app up to Azure DevOps, my Git repo in Azure DevOps. So I'm now going to go to Azure DevOps, and this gives me an opportunity to take a quick little look at a brief scan of my code repository and the various elements of my solution. So what we're looking at is Azure, my Azure Data Analytics demo. So this isn't live production code. It's just demo code based on solutions that we've done for customers. And I've organized the code such that I have Data Factory, and we'll talk about Data Factory in a minute. I've got some deployment helpers that ARM templates and PowerShell scripts to deploy ARM templates for the various components of my solution, some documentation, the functions that we're just looking at, logic apps, which we'll get to in a little bit, and some other scripts, test data that I use to drive some actual tests themselves, another test solution, various tooling, and so on and so forth. So even though I have a vastly different vastly different technology, it is all Azure, but different services, logic apps, function apps, data factory. I could also add other services in here. I put them in a single repo. That's how I've chosen to organize my source. The key thing is I've managed the source. I've got traceability to the source, and I can see and manage and monitor check-ins. I can also put in policies that say I'm not going to. I trust myself, so I just pushed to my main code. But I could say, hey, if I'm on a development team, I want to make sure that there's a reviewer for this code before it gets into my main repo and it's eligible for release. That could be true for data factory code, data factory configuration. It's really a bunch of ARM templates, and again, we'll get to that in a minute. My function apps, my logic apps, models, again, analysis services models, whatever it happens to be. We can do this with Power BI as well, but that's a whole other topic that there's been past presentations on before that I'm not going to get into today. So we've deployed this, or I've pushed code, and theoretically, while I was talking, I see that at on 8/15/12/23 U.S. Central Time, we queued up a build, and good news, my build actually passed. So what we're looking at here are build pipelines in Azure DevOps. Again, I'm at dev.azure.com. This is a sample organization. AZDA-demo is my project. And here's a build definition for my function app. And again, this is, if you're familiar with building code solutions, even though this is an Azure function, a serverless function, it's going to look somewhat familiar. This is also what is now legacy code or .NET Framework, full framework code, not .NET Core code, though I could certainly support code. And I'm going through a fairly standard development and deployment build pipeline. I'm restoring packages. I'm building the solution using the same solution file that I used on my local machine. In this case, we talk about security. I'm actually running analysis on my packages to ensure that there isn't any security vulnerabilities that have worked their way into my code that might expose secrets or do nasty things in my code or expose me in some other way. I'm also running unit tests on this and making sure that my unit tests pass. Then I publish this artifact. And again, the act of publishing the artifact allows me to use it in release pipelines. I haven't actually deployed anything to Azure at this point. I've just built it. I've made sure that any changes that come in from various team members are all going to be built in a central repository. So hopefully I'm moving at a reasonable pace here. I'm going to keep moving because time keeps flying. And then I've created a release for this. So I've done a build, and now I'm going to actually release it. So if I look at demo function release and we see, oh, hey, here's a situation where I have two stages, and if you recall my presentation from a few minutes ago, I had boxes on a diagram that I had dev, test, security, stage, prod, so I can easily add stages for demo purposes. I've got dev and test, and we see that, hey, I've deployed to a dev environment. It's still working on the test environment, and we can take a look at that in a second. I'm going to go in and edit the pipeline. And what I've done here is this artifact represents the build, the results of the build that we just looked at. So every time I build, and if my build passes, I'm going to push that build into my development environment. And what am I doing in my development environment? I'm actually doing a deployment to Azure. This is a task that will take my deployed bits and push them out to Azure. I have a service connection. This is a connection that I set up, or somebody who has authority to my Azure subscription can set up for me if I don't have access, so that my Azure DevOps pipeline can publish into my target subscription in Azure. As a developer, I may not have access to that Azure subscription, but that doesn't mean I can't deploy to it in a secure way. I can deploy to it in a secure way. So I've passed, I'm passing a number of things, doing deployment into my my application site. I also, my dev environment is not going to be the same as my test environment, is not going to be the same as my staging environment, is not going to be the same as my production environment. This being a function app, I'm talking to, pulling in data. In a development environment, I'm not going to be pulling in production or live customer data. I'm going to be pulling in test data more than likely, so I want to point to a test data feed. And I can easily variabilize or parameterize my my deployment, and what I'm doing here in a PowerShell script is basically just, hey, when I deploy this, I'm going to set up some parameters. Again, the specifics of what's in the demo function don't matter. We can certainly, if we have time at the end, go into more detail. The critical thing I want to point out is I've got an argument here. I can pass in a parameter, and I can parameterize it, and I can pass in environment name or env name, and that's basically going to represent dev. So if I look at variables, for example, I've got an env name, which is going to be dev if I'm in the dev environment, and test if I'm in the, or actually in this case dev if I'm in the dev environment, but test if I'm in this other environment. That should be test. Bottom line is I can parameterize these deployments and have a set of files that I can reuse in the different environments. This basically reduces the amount of work, as well as instead of me copying files around, I'm leveraging assets that I've developed in different elements of the pipeline. And if dev passes, which it did in my case, it'll immediately go to test, and test is going to look awfully familiar. It's leveraging some of the same files. I have the same parameter, but it's going to pick up a different configuration file so that my function will know, hey, I've got to talk to the test endpoint. Don't talk to the dev endpoint. Certainly don't talk to the production endpoint. These variables are actually applied to my deployed site via this other task. And then a critical thing that I do once I've gotten my function app deployed, once I've set the environment correctly so I know what it's pointing at, I run a simple integration test. And in this case, my integration test is just a PowerShell that's going to go hit the REST endpoint, pass in some variables, and then make sure I get the expected result back. If I don't get the expected result back, I throw an error, and I have a gate. I stop the deployment from proceeding through the next gate. So let's just double check my pipeline, and we can see for my demo function release, we can see that, yeah, I actually got out to test. What's interesting here is I can also see the history of deployments that I did. A few last night while I was checking, and then the last time I ran this demo months ago, I can see, hey, this release 59, what was in that release. I can go in here and check logs, and et cetera, check the artifact. I know exactly what went into that artifact, what the code change was that went out previously. Or looking at the current release, I can see what's in my, what went out the door in my my current release. And if I wanted to, I could even send an email to somebody saying, hey, here's all the stuff. Here are details on the release, the various stages that it went into, a whole by the way, this live environment, it's really not ready. We haven't deployed to it. But I can see that, yeah, I got it to dev, I got it to test. Any issues that were generated through, yeah, I got to tweak some of my deployment scripts. And then if I had work items, so this would be a customer request, a bug fix, something like that, I can see what went out the door for this bug fix. Again, very classic development sort of scenario type things that apply just as well to data analytics, especially these days with all the automation that's available to us. I'm not going to send an email. I don't know who I'd send it to other than myself, and I really don't need it. So I'm going to go ahead and cancel that. So hopefully, I didn't go through that too fast. You can kind of see the idea. I've taken one element of the solution. I scripted it out. Whenever I make a change to the function app, it really didn't take me very long to script this out, but whenever I make a change to that function app, it runs locally. I verify it. All I did was commit that to my source repo, and I've now have that function app both in my dev and my test staging environments. And if I wanted to, let's say I go in and edit this pipeline, which we took a look at this before, and say, yeah, I'm really happy with what's going on in dev and test. I now want to get this out to another environment. I can go clone that, say, now I'm going to go out to stage, and down here in my variables, as long as I provided a parameter file for the staging environment, everything else is just going to work. And almost just going to work. I have to make sure that I am deploying my function out as well. So again, just to take another view at this, I'm now looking at my Azure subscription. I don't really need to look at this. I've deployed all this without ever touching Azure myself. I let Azure DevOps do that for me. But if I look at my AA Dev environment, I've updated a Azure function. My demo function app has been updated in my dev resource group. The way I set this up, I created a development resource group and a test resource group. This deployment could be happening to completely different subscriptions if I so desired, right? I've got a dev and test subscription, and maybe I likely have a different production subscription to segregate that. Nope, that's also not an issue. I go back and take a look at my AA test resource group. I have again, a app service demo function app that is running in test, which is what was just deployed to. Okay, so that was our function app. Fairly classic development lifecycle, continuously deploy. All I did was do a check-in, and I've got an updated development environment and an updated test environment. My test passed in dev and test, and I'm good to go. So I'm going to transition now to Logic App. And Logic App is a little bit different animal. I can edit my Logic App locally, but there isn't really a local runtime. And also, it's not a classic build. It's really just some ARM templates or JSON configuration files. So my deployment is a little different, but I can still go through and follow the same process. So if I bring up my Logic App, I've preloaded it, and I've got a development environment. Again, this is Visual Studio. This is local. I can go in and do a quick modification on my Logic App and say add something to my app, or if I'm going to append a string, whatever I can do here, I can go ahead and change it. I'm going to go ahead and save. I go through, now unfortunately I can't do a local run of this Logic App. I'd like to be able to do that so I can test it locally before I deploy it. I can't really do that. But I can still go through the idea here, push it out, again, in the interest of time, because I do want to get to Data Factory, which is more interesting. I'm going to keep moving. I can go through the same process here. And if we bop over to Logic App, we'll take a quick look at the build pipeline for my Logic App, where I package it. We can see, again, multiple quote-unquote builds have taken place here, but what does my build actually look like? All I'm doing is taking the JSON configuration files, grabbing a test script, I'm packaging those up, and I'm publishing them to an artifact directory. Typically, if you're doing some transformation on your configuration, or let's say I'm doing some substitution or something in the Logic App, build might be a good time to do that, because then I do it once and I deploy that same artifact to multiple different stages. Here, since all I'm doing is a simple copy, one could argue there isn't really a lot of use to doing this copy, but I do have an artifact that I've packaged that I can then use in my release pipeline. So if I go to my release pipeline and I look at my Logic App, I see that I've got builds, and again, last night anyway, I deployed this into dev and test, and if I take a look at that pipeline, I'm going to be doing something fairly similar in that I have I'm doing an Azure deployment where I'm using my service principal subscription to Azure to actually do the deployment, and then I've got configuration parameters here. All right, this is actually going to dev. I hard-coded dev right in there this time. That's fine. This is my dev stage. And then I'm actually running a test. This is a Logic App that's HTTP triggered. So again, I just do a simple PowerShell script that executes against the Logic App to make sure that it's going to run. I deployed something. I want to execute it, exercise it, make sure that it runs. And if it doesn't run, stop execution. So again, fairly straightforward. I look at my pipeline. As long as my test execution works, I'm going to push it into the test stage. Test does the same thing. It's going to deploy it out to, this time, to my test resource group, and then, again, run a test on it to make sure that, hey, that URL is, that Logic App is live, and I'm exercising it, and we're all good, and I'm going to keep rolling through this, keep rolling through my deployment. Then the last thing, and arguably the most interesting thing, the most complex thing, is our friend Data Factory. And if you're familiar with Data Factory, you know that the quote development environment unquote is actually inside the Azure portal. I don't have Visual Studio. I don't have a separate development environment that I can use to modify my Data Factory. But the Data Factory team has built some hooks into the Data Factory environment that allows me to do the same sort of deployment. So what I've done is I've said, hey, Data Factory, connect this to my Git repo in Azure DevOps, and allow me to configure what my collaboration branch is. So this allows multiple different people to work on Data Factory at the same time and commit them into a single branch that can then be deployed further on down the road. So it's actually some very nice features for collaborative development. And it's nice even if you're the only person who's working on it. So I can do something like go into my pipeline or data set, doesn't really matter. I'm not going to make a meaningful change here. I can go into general and say, hey, put in a description. I'm going to go ahead and save all. Yeah, we've saved, and now what I can do is publish this, and that's going to push my change out to Data Factory. and that push to Data Factory is going to do the same sort of thing, though slightly modified from my function app or logic app. And while it's pushing stuff out, I'm going to keep running. Actually, I'm in the browser already and show you what's going on for logic app. There is no, given that my development environment is in Data Factory, there is no corresponding build in my demo environment here. I've got a build for the logic app and a build for the function app, and no build for Data Factory. I do have a pipeline, however. So if I look at the Data Factory pipeline, we can see I just have one stage and I don't have dev. We do see that the test stage has been triggered, however, and that was triggered because I just did a publish. So in this Data Factory, I hit publish. That pushed code into my Git repo. That push into Git repo triggered the build. So let's take a look at that at my Data Factory pipeline. Again, I just have one job here, and my artifact is actually Git, and specifically, there's a branch, a publish branch that gets created when I hit the publish function in Azure Data Factory. So I go into Azure Data Factory, I hit publish. It's going to push this into, push my changes into the ADF branch in Azure Data Factory. So I'm triggering my release on this branch. When I trigger, I'm going to take everything that was in dev, got pushed into my repo. I'm going to go get keys out of Key Vault. I'm connecting to services. Those services need to be secured. There's credentials that are required, so I need Key Vault to go talk to. In this case, I've got blob storage. Again, this pipeline is incredibly simple. All it's doing is taking files from one folder in blob storage and copying them to another folder in blob storage. Not very exciting into itself, but obviously a real-world solution would do interesting things to those files. But I got to be able to connect to that blob storage, and those blob storage accounts are going to be different by resource group, right? If I'm running in my dev environment, I've got one set of folders, and if I'm running in my test environment, I've got another set of folders. And how do I handle that? Well, in test, I say, hey, go get keys out of my Azure Key Vault. I then have transforms that so I get keys. I stop triggers, so I have triggers firing, timer trigger, HTTP trigger, whatever the triggers are. For my Data Factory, I got to stop those triggers so I can deploy. I then deploy Data Factory, and then I fire my Data Factory back up. And in my deployment, I'm passing in Data Factory parameters. I'm passing in the template itself, which was generated for me on publish. I'm passing in template parameters, and then I provide some overrides because, hey, I've got linked storage, and that connection string is specific to my test environment. So with not a lot of work here, I've duplicated my Data Factory from dev to test. Okay, and you can imagine that. Sorry for a little bit of clicking around there. If I go back to my pipeline and I say, yeah, I'm good, I can do the same sort of cloning here, and as long as I provision my environment, I could take that test Data Factory and put it in another environment, connect it perhaps to staging or to production or live connection points with very minimal additional effort. So again, Data Factory, this capability has been around a while, but historically Data Factory has been, if people aren't doing this sort of configuration, it can be a bit of a pain, and people will build custom PowerShell scripts, and there's a lot of different sort of solutions that people develop. to get this deployment to happen, I'm leveraging Data Factory as well as some of the connections that Data Factory has provided to get to make that connection. So if I go back to my presentation and just to summarize, so our development environment in Data Factory is the Azure UI. So Data Factory is providing some things for me. So if I'm in Data Factory making some changes, I can save. It's going to save to master. I saved it, make another change, save it to master. Other users could go pull this code and deploy it if they so desire. I hit that publish, and I published it to master and then created this ADF publish branch. That triggered test, right? And again, if I so desired, I could pretty quickly create staging and prod environments as well. So again, hopefully that makes sense. And if I keep moving here, we'll have time for questions if it doesn't make sense, or if we can review some of the files in more detail. So I talked about service connections. Just to reiterate the point, I'm orchestrating my deployment. We talked about dev and test primarily, but I could pretty quickly add additional stages here. Each of those environments has a service connection that is connecting to a resource group. In the case of dev, I'm connecting to my dev resource group. In the case of test, I'm connecting to my test resource group. Resource groups are certainly a good way to collect those resources together. Like resources together, I might have 6, 7, 8 different elements of my solution. I pull them all together into a single resource group. These could be across different subscriptions entirely, especially if I'm going to production. It's likely going to be a different subscription. And again, the connections are given access to admins. They have to be made by somebody who has authority to deploy into these resource groups. As a developer, I may or may not have those privileges. So these service connections allow me to proxy and do a deployment without having access to the Azure subscription directly. Now, we talked about Key Vault a little bit. We can get into this further if you so desire. ARM templates. I'm going to keep rolling here as we get toward the end of the hour. So summary and takeaways. Again, we explored the sort of the concept of continuous deployment, the fact that continuous deployment can be done with Azure Analytics solutions. Everything today, we have ARM templates, we have Azure Cloud Shell, PowerShell, the Azure CLI, various tools at our disposal that allow us to automate our deployments. That isn't good enough, though. We have these various building blocks. I want to make sure that I have tests in place. I am putting all my code into source, et cetera, et cetera. And then, the benefits are, look, I do this automation, and you can see, if I had something that was actually useful, within the course of an hour here, I could have deployed changes to production, even if it was Data Factory, right? It doesn't take long. Certainly, it was more than an hour to put it together, but it wasn't that much longer, right? So I do have a couple of other resources here that I can provide, and at this point, both DevOps, there's plenty of out there on DevOps. There's some resources that I have that I like, as well as further background, further reading on Data Factory deployment, good ways to, hey, how do you test Azure functions, and et cetera, et cetera. So resources that I found helpful. So hopefully you all got something out of that, and I think that brings me to a close to my material, and I'm ready for questions.
All right, excellent. Thank you, Phil. So we do have a number of questions here. The first one is how do you enforce the constraint? Let me reread this real quick. How to enforce the constraint ACID compliance in ADLA similar to relational data warehouse?
Yeah, so that's getting into the details, but that's by code or by convention. not by definition. So the expectation is, you've got tabular data, or a file of data, and you're basically having to build that. The advantage is I can process gigabytes, approaching terabytes. That is probably going to be difficult for me to do in SQL, let's say, or expensive to do in Azure Data Warehouse, which is another way I would do that. But if you've got the money, Azure Data Warehouse is another way to do that.
Okay. And how does it work with ADF if there's an SSIS runtime involved?
Yes. It's challenging, but the same applies. Where that deployment, the deployment specifically for the SSIS would be handled typically separately because of the logic that you have in it, but the same sort of rules apply. The other thing you have to watch out for with Data Factory and with runtimes is when you're deploying, you've got more things to stop, right? So I stop triggers. I may have to shut down the runtime temporarily while I'm doing a deployment, then restart it back up. We didn't talk at all about infrastructure as code, which is, that's at least a talk, right? I'm assuming that all these resources exist, but I can also script out actually firing up Data Factory, which would include firing up integration runtimes. And there's a little bit of catch-22 with the when you're doing that with Azure runtimes, where when I'm doing development, I can start up my Data Factory, add a runtime, and connect it. Now, when I go to my next stage, I've got to be able to detach the runtime because I don't have it yet, deploy the runtime, then deploy the Data Factory, then deploy my runtime, reconnect my connections, fire up my runtime. So, hopefully that makes sense. But SSIS is an additional challenge. Certainly can be done. That, again, don't have it demoed, but the easy answer is yes, it's possible. The hard answer is, all right, specifically, how do you do it?
Right. Okay. And what kind of tests do you have on Data Factory? Are they PowerShell scripts? Also, how do you handle secrets within the tests?
So the secrets. So firstly, the testing Data Factory is a challenge. So if I think about, I need to think about what my factory is doing. So in my case, it's pretty simple. There's one single pipeline. So I don't really have a way to unit test the components here. I've got to test the solution as a whole. So part of what my logic app does is it inspects the, and in fact, let's see if I still have it up, just to illustrate the point here quickly. No, sorry, it's not that one, this one. Forget I said it. So what this does is on HTTP request, it initializes some variables and it lists out all the files that are in a blob. So it's expecting that, hey, if I've run a test, I've put data files into my input directory, and then in some amount of time, I'm expecting them to show up in some form in my output directory. So that's what my test does. And then I'm gonna, in this case, it's semi-automated, right? So I'm gonna trigger it, and I'm gonna trigger it as part of my deployment. I just say, hey, I've deployed Data Factory. Trigger this logic app. The logic app is going to go list and make sure that files exist in my output directory, and then send me the results. So that's what I can do here. And then depending on specifically what your Data Factory does, you're going to have to be doing the similar sort of thing. Hopefully that makes sense.
Yeah. And then one of the attendees noticed that the Azure Data Factory start and stop triggers were in preview, and they don't seem to be in his Azure DevOps. Do you have any input on that?
I don't. This is not, the task is not required. It's sort of a helper task. What it's doing is, where the heck am I? Data Factory. So Yeah, this can be done from the Azure CLI, for example. It doesn't. You don't have to have this task. So is my only real response there.
Okay.
And again,
And then all right. And then we do have a couple more questions, but we are pretty much out of time here. The last ones that I'll kind of group together is that there's a couple of people asking for your slides. And if you can make those available, I can put them up on the meeting archive so that folks can access those after the fact.
Sounds good. I'll send them your way, Jason.
All right. Great. Well, thanks again, Phil, for presenting today. This is excellent. Everyone, thank you for attending. There seems a lot of people were very interested in this topic, so we'll probably have to have a few more, some more coverage on this over time. But again, thanks, everyone.
Thanks, everybody.